I hope you're all feeling well. In 1971, my country, the United Arab Emirates, was created. And ever since then, it has been investing in human capital and developing its satellite operator companies, research centers, and Earth observation capabilities, as well as related infrastructure and facilities in order to further develop its space sector. In 2014, the United Arab Emirates announced the establishment of the first Arab Space Agency and announced that it's joining the space exploration community with its ambitious Emirates Mars mission, EMM, and its HOPE probe, a spacecraft destined to orbit Mars in 2021 to coincide with the 50th anniversary of the country. In 2017, the UAE announced the UAE astronaut program and the Mars 2117 project to build the first city on Mars by 2117. 2 days ago, we also announced the very exciting creation of a Martian city over an area of 1.9 million square feet in the UAE. The UAE Space Agency and the Mohammed bin Rashid Space Center are preparing short and long-term plans for the implementation of the Mars 2117 project. To learn about the very exciting initiatives and about the UAE sector and the landscape, please allow me to introduce His Excellency Dr. Mohammed Al-Ahbabi, Director General of the UAE Space Agency.
Good afternoon, everyone. It's a pleasure to be here, and I would like to thank all of you for your interest to know about UAE space program. In my remarks, I would like just to give you a high level of UAE space story. As Sheikh mentioned, our space program, it's not new. But there's a question always we have been facing is why space? Why UAE in this part of the world at this particular time has this great ambitions in space? Well, we are no different than other countries and other nations. We understand and we appreciate the value of space. We know that space provides strategic benefits. Economically, it's great to diversify and bring knowledge-based economy, and also bring great benefits to people, especially in social life. We also, as UAE, we do understand our leadership, our government, and our people, that space is a great platform for innovation, is also a tool to inspire young people, and also a model for diplomacy and cooperation. For these reasons, our visionary leadership long time ago realized space is part of our current and future. And this is why the UAE space story began. Today, United Arab Emirates space sector is considered to be the largest in the region in terms of investment, in terms of capabilities, players, and number of satellites, and also a new domain of space, which is space exploration. In our region, in the past, and even currently, most of the countries focus on space services, buying satellites and using satellites. But UAE has brought a new domain, which is space science and space exploration to the region for different reasons. UAE is working as a powerhouse for our region, working as a model for better future, not only in space, but also in other sectors. Take aerospace industry, real estate, renewable energy, and you name it. And we try to bring hope for better future, especially in the region youth, which is considered to be the largest of the region population. Our space program is for peaceful use and for the benefits of our people, our region, and humankind. And this is why UAE is interested in space. This is why UAE is launching space exploration projects. And this year, we have 3 major projects was announced by UAE governments in the area of space exploration. And my team and my colleague will give you more information about these projects. As Sheikh mentioned, in 2014, UAE government realized that space is an important sector to be developed, and they create our space agency. Our space agency is mandated by the government to regulate and coordinate and facilitate the growth of our space sector. We also, in the last 3 years, we were so busy trying to implement the agenda of the government and try to match our visionary leadership's ambitions in space. We also tried, and we are convinced and believe that in order for a successful space program, we have to do it right, and we have to be part of the international cooperation, especially in the area of space exploration. But also, internally, we have to be organized in the country. So our space agency in the last 3 years has been working on the legal side or the regulation side. So last year, we have issued our national space policy. As I mentioned, our program is for peace, and we are transparent of our goals. So the government issued the space policy last year. We are working on a strategy, and I think it's going to be issued probably this year. But also, we are working on a very important document, which is space law, the law that for tomorrow, not for yesterday, considering the new trends in the space industry. Today, our sector enjoys great support from our government. It's also our space players, where we have regional space leaders in the area of satellite communication, remote sensing, and also, as I mentioned, space exploration, which is the topic of this discussions. We have also, as a space agency, we are focusing on building capacity. We do believe that our space program will not be successful without the human factor. As we heard in the previous session, that skilled people, or the question was how to get skilled people, how to hire smart people in the space industry. It's critical that space needs skilled, qualified, trained engineers or staff. So we are focusing greatly on inspiring, educating, training, and engaging young people to be the future workforce of our space program in the future. We have also very active in international cooperation. In the last 3 years, we managed to sign more than 16 space cooperation agreements with almost all space nations. In fact, only probably 2 space agencies that we have not signed, and it's in the pipeline. Because we do believe that space is all about cooperation and collaboration and partnership. We are so excited and we are so proud of what we are doing. And we will continue developing our space sector for the benefits of our people, our region, and humankind. Thank you so much.
Thank you, Dr. Mohammed. The UAE has a national space program, which includes many exciting pillars. The UAE will develop an initial detailed plan covering all the activities that should take place over the next coming years, dealing with all the technological, logistical, and technical aspects of the program to pave the way for developing a comprehensive roadmap with a clear path towards achieving the ultimate goal of Mars 2117. Please welcome Engineer Salim Al-Marri, Assistant Director General at the Mohammed bin Rashid Space Center, who will take us through the introduction about the Mohammed bin Rashid Space Center, their activities and projects, and will shed some light over the project of Mars 2117.
Thank you, Sheikha. Good afternoon, ladies and gentlemen. So I'll give a quick introduction to the Mohammed bin Rashid Space Center. We are an entity that was established in 2006 as the Emirates Institute for Advanced Science and Technology. And in 2015, there was a rebranding and name change of the center, and also an elevation in the government structure to the Mohammed bin Rashid Space Center. The vision of the center is to be recognized globally as a center of excellence in the field of space science and technological innovation. And really the way we want to achieve that vision is by focusing on very innovative and unique missions, and also developing those missions through youth, and obviously focusing on development of space or STEM education programs through universities. Currently we have about 200 employees at the center. The average age is about 27, and we expect obviously the youth from the center to be able to participate in these innovative programs, such as we've seen in previous programs such as the Apollo mission and others. If we look at the national space program that we have at the Mohammed bin Rashid Space Center, it is focused on 4 main programs. The first is the UAE National Satellite Development Program, which encompasses all of our satellite development. And my colleague Amr at the end there will be speaking about that later on, so I won't give more information on that. The second national program that we have is the Emirates Mars Exploration Program, which has the Emirates Mars mission as its first and main program. My colleague Adnan, who's third, will be speaking about that after me, so I won't give you more information on that. I'll be focusing on the last 2 programs. So we have the Mars 2117 strategy, which is quite an exciting strategy to put a 100-year plan, a generations plan. So we expect multiple generations in the UAE and the world to be working on this plan of putting a long-lasting colony on Mars. One of the first projects, as you heard from our colleagues before me, was the Mars Science City, and I'll talk more about that in the next slides. The fourth and final program that we have is the UAE Human Spaceflight Program. This is an initiative from the UAE government to have a sustainable human spaceflight program for the country. And when we talk about sustainable, that means that we are looking at, obviously we're not looking at launching an astronaut for a week or launching, as they say, a tourist flight. We're looking at a program that is based on science. So science principles that are linked with our long-term strategy. So as you can see, if we have a long-term strategy of getting to Mars by 2117, then our astronauts would be working on science that is related to long-term habitation of space. So what we want to do is we want to go through a selection process sometime soon. We will choose a group of astronauts as our astronaut corps, take them through the basic training and then professional training of astronauts, and then have a flight sometime at the end or close to 2021. So if I go into more details now, I would like to talk about the project that was, the exciting project that was announced a couple of days ago, which is the first project under the Mars 2117 strategy, and that is the Mars Science City project. So, as I mentioned, this is part of the Mars 2117 strategy. It'll be about a 2 million square foot project. This will be the largest space simulation city ever built. So as you very well know, there are many projects such as the ones that we have in Hawaii on the volcanoes, and such as the Mars 500 initiative that was out of Russia. Those projects are very unique in that they focused on human psychology and how humans would interact with each other on a very long duration space flight. There were also other aspects related to that. This project will be doing something very similar as well, but it will be focused on 3 core areas. Those three core areas are energy, so what kind of energy generation you would have when you go onto the red planet. Food, so food security, securing enough food, and also water recycling and generation. So how can you be as efficient as possible in maintaining those 3 aspects which are very important for life. So it will also include a realistic simulation environment depicting the conditions on the surface of Mars. And obviously, we will also plan to have a team that would be living and working in the city for over a year. So you have a long-term we'd say, life experiment of how it would be living on Mars, that would focus on the psychological aspects, but also focus on, how they're going to be growing their food and what technologies would be used, etc. We believe this would be a reference model for future innovation around sustaining life in a hostile planetary environment. Also, anything that would be done here can also, first of all, be, would be taking, the next steps from the initiatives that are already being done around the world and by other agencies. But also, there are plans that we're very well aware of, such as ESA's Moon Village plan. So, anything that they would have in the pipeline of actual research could also be supported by the Mars Science City project. And obviously, as I mentioned earlier, there'll be laboratories for food, energy and water, and agriculture testing, as well as studies about food security in the future. Another exciting aspect would be also there'll be a museum with 3D printed walls. The idea of using 3D printing to build such a structure, 3D printed walls using sand from the UAE desert as one of its main products that would be as one of the main products. So that would also focus on, looking on when you go to Mars, one of the best ways, or one of the ways that you could actually get a structure up would be to use Martian soil or regolith or whatever it may be and obviously 3D printing would be probably the easiest way to be able to do that. So through this city, there'll be some testing and some work on that. The museum itself will display some of humanity's greatest space achievements, and it will have educational areas to engage young citizens and interested people in space and help them, if they've got a passion, this would be an area that would be growing. So thank you very much. That's an introduction to the Mars Science City. Now I'll just go slight details into the UAE astronaut program. What I would like to add on what I said before is obviously a lot what we expect from this science city is that we would also connect with the global scientific community. So if there are scientists studying food security or whatever it may be, that is something that they could also partner up with us on, and we could work together on that. With our astronaut program, a lot of the scientific experiments that would be done in this environment eventually would have to go up to space to be tested in that environment. So we look at that as a natural next step and a progression towards testing some of our experiments and ideas in the ISS and in the space environment. And we're looking at partnering up with all the space agencies on that one. So I will hand over now to my colleague Adnan Al-Rayis, who will talk about the Emirates Mars mission and give you more details on that. Thank you very much.
Thank you, Salim. The Emirates Mars mission is the first Arab Islamic exploratory mission. The objective of the mission is to gain better understanding of the Martian atmosphere and the interaction between the various layers. The project has already succeeded in obtaining and utilizing existing space sector capabilities, which rely extensively on the UAE nationals, exemplified by Mohammed Rashid Space Center and the UAE Space Agency. Please welcome to the stage Engineer Adnan Al-Rayis, Deputy Project Manager, Ground Networks from the Mohammed Rashid Space Center.
Okay. Thank you, Sheikha, for the introduction. Good afternoon, ladies and gentlemen. I'm very pleased and honored to be here to introduce to you the Emirates Mars exploration and our catalyst project, the Emirates Mars mission, or is known as the HOPE probe. In the following slides, I would like to walk you through different aspects of the Emirates Mars mission, starting from the science behind the mission, the scientific questions that we're trying to answer, and those also driving the design of our spacecraft, our instruments, and our orbit as well. Also, I'd like to highlight on the operation and the launch segments of the mission, and also update you on the current status of the development of the mission. But before jumping to the science, let's go back on how the whole story started. So As mentioned earlier, in 2014, we had an important announcement by His Highness Sheikh Khalifa bin Zayed Al Nahyan, the President of the United Arab Emirates. Two important announcements that significantly impacted the space sector. One, the establishment of the UAE Space Agency, the federal entity to lead the space sector, regulate it, and set the strategies for the sector. Two, the ambitious plan of the UAE to explore the red planet. And the mandates given by the government is basically one, to reach Mars by 2021, coinciding with the 50th anniversary of the UAE. Two, to do a unique science never done before with the previous missions. Three, to support the development of the STEM education and encourage the young generation to join the science fields. And fourthly, this is something that should be done in coordination with international space community. So this is the way how it started. And the teams from the UAE Space Agency and Mohammed Barrage Space Center collaboratively set up the whole plan and on the development of the mission. Accordingly, we teamed up with 3 main universities in the United States, the University of Colorado Boulder, University of California, Berkeley, and Arizona State University to work together on the different aspects of the implementation of the mission. So, on defining any deep space missions, the most important thing is to define the science, because the science defines the, as I mentioned earlier, the design of the spacecraft, instruments, and anything, and those comes at the later stage. So what is the science motivation behind the mission? So the first thing that we did is that we coordinated internationally with the Mars Exploration Advisory Program, that's the MEPAC, where they basically looked into the different scientific questions, and we looked into the gaps in the human knowledge about Mars. Actually, we found that there is a gap about the Martian atmosphere. Currently, with the existing missions on Mars, they study the Martian atmosphere during certain time of the day and night, leaving more than 80% of the Martian atmosphere unexplored. So the existing mission, they are limited with the local time, like, for example, every day at 2 p.m. and 2 a.m. they study the Martian atmosphere, and also they do have a very limited viewing geometry. So they basically study certain area. Taking those into consideration, we came up with the main scientific objective of our mission, which is going to be the first mission that will provide us a global, seasonal, diurnal, day-to-night coverage of the Martian atmosphere. You can imagine as if it is the weather satellite for Mars. So with this, we're going to have the global coverage of the Martian atmosphere during different seasons, day and night. And this information and knowledge and the science that will be generated by the Emirates Mars mission will be available to the scientific community around the world. Here we have the main 3 questions defined by the science team. 1, how does the Martian lower atmosphere respond globally, diurnally, and seasonally to the solar forcing? 2, to study the atmospheric escape rates. 3 is to how does the Martian exosphere behave temporally and spatially. And from those 3 science questions, here we have the science flow. I don't want to go through all of that, but I would like to show you that we have a robust analysis and investigations coming from these science questions to these science objectives, which are based on the characterizing the state of the Martian lower atmosphere and correlating the rates of thermal and photochemical atmospheric escape with conditions of the collisional Martian atmosphere, and different characteristics that we are going to study. Those are all linked with these science investigations. We have 4 main science investigations, and we did coordinate with the MEPAC. And accordingly, we found that we are answering the second scientific objective that the MEPAC has, which is basically studying the history of the Martian atmosphere. Based on those scientific questions, objectives, and investigations, we designed our mission. So we have the science questions clearly defined. And in order to translate this into data and information, we need to have the instruments that will collect those data. we have came up with a design of 3 main instruments of our mission. I'm going to go through them very quickly. The first one, which is Emirates, which is an infrared spectrometer. The second one, which is the EMUS, the Emirates Mars Mission Ultraviolet Spectrometer. And the third one, which is the EXI, which is the imager. Go through those 3 main instruments. The first one, which is the EMUS, which is the far ultraviolet imaging spectrograph, that will characterize the scape of the hydrogen and oxygen from Mars and the state of the Mars atmosphere. It has a spatial resolution of less than 300 kilogram on the disk, which is sufficient to characterize the spatial variability in the Martian atmosphere at an altitude between 100 to 200 kilometers. The second instrument, which is the EMIRS, so there's a mistake here. This is the EMIRS, which is Emirates Mars Mission Fourier Transfer Infrared Spectrometer. And it's based on it's the 5th generation of this device and developed with the Arizona State University. Thirdly, we have the EXI, which is 12 ampex CMOS imager, which is operating at the ultraviolet and visible bands, the blue, green, and the red bands. And the science products that we are planning to monitor and detect, one, the dust column, integrated with the optical depth, water ice clouds, the ozone, and the color images of Mars surface. So those are the 3 main instruments that we have on our mission to Mars, and here where the 3 instrument suites will be located on the main spacecraft. The spacecraft has a total width mass of 1,500 kilogram with a dimension of 3 meter by 7.9 meters. 7.9 meter, we're talking about deployable solar panels. So we have, it's a 3-axis stabilized with 2 large deployable solar panels. We are communicating with the ground network using the high gain antenna using the X-band. We have 3 low gain antennas which are used during the early operation phase all the way to cruise. And once we reach Mars, in order to download the data, we shift to the high gain antenna to download all the data. Let's have a closer look on the location of the 3 instruments, the EMIRS, EMUS, and EXI. So in order to achieve our scientific goal, which is having the global diurnal day-to-night coverage, we have to also define the observation sets from beginning. And in order to do that, the location of the 3 main instruments is very important for us in order to be able to coordinate between the 3 instruments to collect all the observation and achieve our goal. But this is not enough yet in order to achieve our global coverage goal. We designed our orbit so that we're going to have a 55-hour orbital period, which means that every week we have 3 orbits. So 3 orbits per week, very high elliptical orbit, which allows us to have this global diurnal day-night coverage of the Martian atmosphere. If you look at the other orbits of the other missions here in this chart, you can see the MAVEN and other missions have very close orbit of the Martian of Mars, which won't help in having this global diurnal coverage. So this is important thing. It's not only about the spacecraft and the instruments, but also to have the orbit that will allow us to explore the Martian atmosphere and provide all the knowledge. So we have 3 orbits per week, and within those 3 orbits we have 2 contacts per week. It's not 2 contacts even per day. It's 2 contacts per week in order to communicate with the ground station and download all the data and telemetry from the mission. So talk about the ground segment very quickly. So in order to command and control the mission, we have 2 mission operation centers. The primary mission will be based in Dubai, and that is the Mission Operations Center, the MOC. And that will be interfacing with the DSN. So we partnered with NASA to use the DSN in order to communicate with the spacecraft during the different phases of the mission. A backup facilities, we have it in Boulder. That's called the mission support facilities. And our navigation lead is Kinetics to generate the different navigation products. And as part of this mission, we have also something called MNAV. It's not here on this chart, but the MNAV, which is basically the UAE nav. And as part of this mission, we are developing our capabilities to navigate deep space missions. It's also important to mention that we have a science data center. The science data center is responsible to receive all the data from the 3 instruments, generating all the products, and disseminate and distribute the data through the ESDC, which is the Emirates Science Data Center. The ESDC, which will be available, and here where you find the data generated from the science instrument, available for the scientific community around the world in order to use the data, make all the research about that. The launch segment. So we have signed the contract with the Mitsubishi Heavy Industry to launch our mission in 2020. So hopefully in July, August 2020, and should reach Mars by February, March 2021. So what is the timeline? Going through it very quickly. So we have the mission launch around the July 2020. Then we have a cruise phase, a 7 months of cruise. So at the beginning, we have like 30 to 45 days of commissioning and LEOP activities, followed by the 7 months of cruise, where we perform the different trajectory correction maneuvers and prepare our mission for the Mars orbit insertions. Once the mission is inserted successfully in the Mars orbit, we have the transition to the science phase. And we're gonna stay in the science phase for 2 years. 2 years collecting the science data, and that is the prime science phase. And the mission could be extended for another 2 years, so a total of 4 years. So where we are right now? So we started the mission as a concept in 2014. We had our critical design review in May this year, and now we are in the assembly integration testing phase and preparing our mission for the launch in 2020. This mission actually shows an example of how UAE, our model basically, in developing missions within our space program or space activities. We have very clear vision that we need to reach Mars in 2020. We need to do something unique. This could be applied also on the other different programs that we have. So with a clear vision that we have, we need to include also the young generation to work together and make use of the data and also develop their skills. This is very important. For the past 10 years, we developed our capabilities in the engineering side. With such mission, we are developing the scientific capabilities. So it is a clear vision with international coordination. As you saw in the presentation, we did coordinate internationally with the international community because we want to do something unique and not to repeat the science here. And also about the international cooperation. In our mission, we selected 3 main universities. So we are working with researchers and scientists developing the missions. We are working with the industry when it comes to the launch and also procurement of the subsystems and the components. We are working also with the international agencies, working with NASA and developing the on the ground network support. We are working with the scientific community around the world, all scientists around the world, to develop the science and the mission. And this is the model that we have in the UAE. It's a matter of the international cooperation, coordination, and include the young generation to do something unique and something different. Thank you very much for listening.
Thank you, Engineer Adnan Al-Rayes, Deputy Project Manager, Ground Networks. Such an ambitious project, and we wish ourselves the best of luck. The UAE has a beautiful story to tell about building capabilities in the country. And like Adnan mentioned earlier, we base it on collaboration with different entities, where today we have reached a point we are able to build our own Emirati satellites on Emirati soil. We are very proud of that. One of the areas that we take pride in is our satellites. And here to speak about our satellites is Engineer Amr Sayegh, Senior Director, Space Engineering at the Mohammed bin Rashid Center.
Thank you, Sheikha. Good afternoon, everyone. My name is Amr, and I'll be speaking about the experience that we went through since the establishment in 2006. So as mentioned earlier, the UAE started seriously to look at space back in 2006. But before that, in the early 90s and end of 1990s, there was some, let's call it commercial activities. And that's when the UAE, along with US, launched the Thuraya satellite, which is a geostationary communication satellite. But that was more of a downstream, more of a commercial cooperation. But in 2006, the government decided that space has to have the major role of driving a much bigger, let's call it a revolution in terms of science and technology in the country. The UAE was established in 1971, and yes, it took a while for the UAE to build the human capital, the human capability. And in 2006, decided that we wanted to go into a challenging and very promising sector, that is space. So in 2006, at that time was called the Emirates Institution for Advanced Science and Technology, now MBRC, went into a 3 phases program in which we will enable UAE engineers to gain and start from scratch and gain and become experts in developing satellite systems. And the 3 phases were as follows. Dubai Sat 1. Dubai Sat 1 represented a phase of 3 years where the knowledge was taken from our partner in South Korea. Why South Korea? There are so many reasons, but the main reason was the openness and the willingness to support us in this, let's call it very challenging and sometimes people look at it very competitive process, which is knowledge transfer. And yes, we went into that program with South Korea, and we managed to launch Dubai Sat 1. Dubai Sat 1 is a typical Earth observation satellite. Let's call it a small Earth observation satellite with reasonable capability, 2.5 meter resolution and 5 meter resolution in multispectral. It was launched in 2009, and it was successfully operating until beginning of this year, where we decided that we will just use it for research activities. And then this was more of a enable these young engineers to understand and to learn about space and how to make space systems. The next phase was Dubai Sat 2, in which in this program we decided let's do a collaborative effort in designing a totally new spacecraft. And not a very simple spacecraft, a very challenging spacecraft and very capable spacecraft, and that is Dubai Sat 2. It is currently in space, and it was launched in 2013, and it provides 1 meter resolution images at 600 kilometers with a very lightweight, around 300 kilograms. So it was a very challenging program where the UAE engineers, along with their colleagues from South Korea also, managed to come up with very state-of-the-art technologies and solutions to come up with this satellite. The third phase, which is enabling these engineers, after investing so much in training them, in building their capabilities, and building their experience, the next step was to give them the full opportunity to take the full leadership in leading a whole new mission, and that was KhalifaSat. So KhalifaSat is being developed in the UAE, and the UAE engineers and experts are taking the full lead in all phases of the program, from design into fabrication and testing. And we are looking for the launch in 2018. What happened in KhalifaSat is we shifted the development. So we have our own facilities in the UAE. We have our team in the UAE. And just as we came back from the knowledge transfer program and the joint cooperation in Dubai Sat 2, the team grew substantially, and we noticed a big interest from the youth in the country, which means having a lot of activities in the country enabled us to expand our operation, expand our capabilities. And that's what happened with Dubai Sat 2 and with Khalifa Sat. So from 20 engineers up to 25 engineers, we have come now up to 130 or 40 engineers. So a lot of the activities in Khalifa Sat are happening in the UAE, and a lot of knowledge is being developed in the UAE by the UAE engineers. And this is the top of our expectation. So within a cycle of 10 years, the three phases of gaining a technology and being an active and a producer of knowledge in this space technology, and then leading challenging projects like Khalifa Sat in the UAE, we completed the 10 years era of localizing space technology in the UAE. Along with that, so sometime in 2013, as the team was preparing to come back to the UAE, as we said, we wanted the continuity of the involvement of the youth in our programs. As mentioned by Salim earlier, the average age of MBRC employees is around 27, which is maybe some people will look at it as a big risk, but we look at it as a long-term investment in the capability of the youth. And we started in 2013 the NIFE 1 CubeSat, and a typical CubeSat program where we support the students in universities in building their own small satellites. And we did the NIFE 1 and was launched early this year, very successfully, and it's currently being operated in the American University of Sharjah by the students. And well, what I know exactly that they are doing a lot of research in terms of communication and understanding the capability of satellites in space. With this first mission, we decided to go into a much bigger program, and that is the Nano Satellite Outreach Program. And I believe within the days of IAC so far, there have been so many presentations and description of the activities in this program. But we can just briefly describe it here as NIFE 1, which was launched, and then the ANSOP 1, and then we are looking forward for even more CubeSats and to continue the support of the academic sector into going into the space technologies through these CubeSats. And then the important thing is to have a sustainable satellite development program. And it can only be sustainable if there is a huge interest, whether locally or globally, of our solutions. And we started with the first solution. So the Mohammed Barrage Space Center is a government entity, and we signed an agreement with Dubai municipality to develop a satellite for them. So this is when the 10 years phase or 10 years era has finished, but now we are going into another era where the satellite development will not happen by focusing on the developing of the capability, but more of finding solutions for, let's call it, problems or challenges that are facing the country. And so we went into a cooperation, and we are developing the DMSat-1, Dubai Municipality Satellite 1, which is the first environmental nanosatellite in the Arab world. And it's focused on the protection of the environment. So let me go back again to describe the satellite. So it's the first satellite that will focus on the environment. And it's a CubeSat around 15 to 20 kilogram. But it will be focusing, it will have the sensors, and the major activities or the major products would be the measurement of the aerosols and the carbon emissions in the atmosphere, which will help us understand and, let's call it, protect our future and maintain the environment in the country. The payload have been selected based on the requirements from the Dubai municipality. So a lot of discussion that was going on in which we eventually found our solution in this spacecraft. So we moved from, as we said, building the capabilities into now building solutions. And as we mentioned, it will be monitoring and measuring aerosols. It will provide data on the greenhouse gases. And yeah, it, hopefully after its launch, which should be sometime in 2019, be an effective product generation tool for the Dubai municipality. So this was a brief of what we have done so far and a history of how we started and where we want to go. And eventually we are planning to build the space ecosystem around us, where we'll have different players from the government or the private sector, all fitting in a bigger plan to support the space sector in the UAE.
Thank you, everyone. We're going to take questions and answers, but let me remind you of everyone who's here today. We had Dr. Mohammed Al-Ahbabi, who is the Director General of the UAE Space Agency, and he spoke to us about the UAE space sector strategy and the space agency itself. We have also Engineer Salim Al-Marri, who is the Assistant Director General of the Mohammed bin Rashid Center. He spoke to us about the center, their operations, the projects, and the Mars 2117 and the astronaut program. Next to him, we've got Engineer Adnan Al-Rayis, who is the Deputy Project Manager of Ground Networks in the Mohammed bin Rashid Space Center, who talked to us about the Mars 2117 project. And last but not least, we have Engineer Engineer Amr Al-Sayiq, Senior Director of Space Engineering at Mohammed bin Rashid Space Center, who spoke to us about satellites. So if you have any questions, please raise your hand. We've got several hands up there.
Thank you. This is a question for Mr. Al-Marri. You mentioned the UAE's human spaceflight program. I wonder if you could talk about when you're going to select an astronaut corps, how many astronauts you might select, and how you'll fly them into space.
Can you introduce yourself, please?
My name is Jeff Faust of Space News.
All very good questions that I don't have the exact answers to, but what I can give you is that we are planning to go through a process, obviously, of we've already announced that the government has already announced that it wants to launch astronauts into space. So the next step for us that we that would happen before the end of the year or the beginning of the first quarter of next year is that we make an announcement for applicants to come forward and apply based on the criteria that we will announce for the program itself. Then we envisage about 6 months to 10 months of a selection process to select the astronaut corps that we're looking at. Currently, we're looking at numbers that are ranging between 4 and 6. Probably towards the lower end, because obviously all of the astronauts that we train, we would also look to fly them at some point. The idea behind the astronaut program is to obviously have a sustainable program, so we're looking 20, 30 years ahead. So we want to put them through that training process and then eventually fly them in the coming years. As I mentioned, we look to have the first flight hopefully by the end of 2021. We have not decided on who will be flying us yet and who we will partner up with, but we do envisage that we'd partner up with all of the major space agencies and somehow in some structure to be able to, first of all, do the research that I mentioned that we want to do, but also be part of the research that the global human spaceflight community is already doing.
Do we have any more questions? I've seen hands. Can we please? Okay.
Thank you very much for a great presentation. I think everything you have presented today is very impressive. And I actually come from South Korea, and I have to tell you that I'm quite jealous of what you're trying to do. During the presentation, you mentioned that the average age of your engineers are around 27. And you also talked about how you trained your engineers, step by step, in order to build capacity. But and a lot of what you're doing is based on the international cooperation. But still, I think you have to have people who are more experienced in order to manage these projects within your own institution. And what is your strategy in terms of getting access to the right human resources or the skills that you need in order to manage all these projects?
Well, I think, as Adnan mentioned, we in MBRSC try to do projects a bit differently. And choosing to focus on the young generation in developing these systems and leading this development of these systems, I think it had a lot of risk, as mentioned. But we do manage that risk through other, again, cooperation. It doesn't have to be a real involvement. What we do is we have a lot of reviewers and consultants who are also working with us in following up on our progress and giving us feedback as we go. That's more of a project management risk, or let's call it risk management in our projects. When it comes to the human resources and then the new people that join us, I mean, we believe that the academic system in the UAE has proven to be quite an advanced one, and most of the members that join us actually come as graduates from UAE universities, and this is something we are proud of. And we are also, again, working with these universities to improve the capability of the students and prepare them so that when they join us, they are even, let's say, the training process is much smoother.
I'd like to take this opportunity to thank you all for being here today. I know there are so many who have many other questions, but because of time limits, I am unable to take any more questions. But we are available at booth 60, just outside, if you want to have more detailed discussions with us on our projects. Thank you all for being here today.